Hello, welcome back. So, in the last video, we had mentioned this concept of a determinant, okay? And we're going to kind of make it a little bit more formal and kind of formalize some of the things we learned in the last video. As well, we'll do an example of computing another determinant of a 2 by 2 matrix, okay? So, let's first just define, so a determinant of, I will do of a 2 by 2 matrix. Okay, so 2 rows and 2 columns. Um, we so let's say that we have a matrix. We'll call it big A. Okay. We'll say that it has A, B, C, D. These are just letters meaning they're variables representing numbers, okay? So if you have a matrix that's 2 by 2 like this, 2 rows, 2 columns, okay? Um, Essentially, the determinant is what we described in the last video. It is the product of these two minus the product of these two, okay? So how we write that notationally, there's several ways that you can write it, is determinant of A. Okay, so we use DET to symbolize determinant. And that is A times D minus B times C. Okay, so you're just doing the product of these two minus the product of those two. Okay, so that's what the determinant of your 2 by 2 matrix is. Some other notations for this that mean the exact same thing is you could write bars around A, so like kind of absolute values around the matrix. That is the same. We'll just say the same. Okay, so it means the exact same thing, just the number A times D minus B times C. And also, you could write this kind of in a matrix form as this, okay? A matrix where you don't put little brackets. These are just bars here. This also means the determinant, okay? So that's what the determinant of a 2 by 2 matrix is, okay? And so I'm going to go ahead and compute one for us, okay? So example. Let's find the determinant. I'm not putting the brackets in because I just want to find this number. Okay, so let's compute this determinant. Okay, well, what we do is we just do these two numbers times each other, so it will be 18, and then these two numbers times each other, but we minus that off, right? So 2 times -3 is -6. Okay, now be careful, there is a minus sign in here, right? So we're doing 18 minus 2 times -3, which is -6. Okay, and what happens when you minus a negative? You get a positive, right? So this is really 18 plus 6, which is 24. So that would be my determinant here. Okay. Now, remember in the last video, I kind of talked about why determinants are important in that it tells you when the matrix is invertible, okay? So this being equal to 24, this will tell me it's not 0, not 0. So the matrix, now with the bars in it, 6, -3, 2, 3. This matrix is invertible, meaning it has an inverse, okay? It does have an inverse, okay? And we could find that inverse if we wanted to, okay? But essentially, just knowing the determinant is not 0 tells you when it's going to be invertible or not, okay? So hopefully that kind of gives you a little bit of an access point into these problems. In the next video, we're going to look at, well, we've only looked at determinants for 2x2 matrices. How do we define them for larger matrices, okay? And we'll see that shortly. But essentially, the same rules apply if you have a 3x3 matrix whose determinant is 0, it's not invertible. But if it is, sorry, I'm getting all confused here. Okay, let's start that over again. If you have a 3x3 matrix whose determinant is 0, you are not invertible. And if it's not 0, it is invertible. Okay, so that's kind of the same thing we're going to run into, but we will need to see how you kind of compute determinants for larger matrices as well. Okay, so hopefully that's helpful. I will see you in the next video.